Hello friends, we are live again. This was not a joke. We're actually doing a second API review today. This time it's pretty late in the day for us, but it's probably still fairly early for James because he's in New Zealand. So finding some common time. So take it away, James.
Okay, so this is adding a property to Socket's HTTP handler, and I believe the proposal has been expanded to also add a property to Win HTTP handler. So the issue we're solving is HTTP2 has a setting called max concurrent streams. This is configured on the server, and it is the upper limit of active streams on a single TCP connection. The reason this setting exists is to prevent a client from doing malicious things like opening 1,000 or 1,000,000 streams active on a single TCP socket. So the server sort of puts a limit on it, and usually the limit is about 100. I'm getting feedback from someone, and usually it's about 100, but it can be a bit higher. So the problem with this setting is today with HTTP client, it will always open a single connection to a host. So for a given host name, there'll be a single connection, and as soon as you hit that limit, so you call send async, or one of the methods which calls into send async, like get async, that method will await, and it will form a queue, so a first in, first out queue, and it will wait for a current active call to complete before it continues. So you have to do this on the client. If you didn't do this on the client and you still attempted to send the request to the server would error. It would send you a message to tell you that you're making too many requests, and for that reason, the client tracks the number of active streams and it will form that queue. So there's a couple of problems with this. One, HTTP client, it's quite common to just have a singleton instance within an app. Now, if you're in a client app, probably having like some thick client, having 100 concurrent requests is probably quite a few. But if you're doing something like one microservice talking to another microservice, and all the requests are going through a single HTTP connection, a single HTTP client, you could easily hit that 100 limit. And it's a little worse for gRPC because gRPC introduces the concept of long-lived streams. So you could create 100 streams that you expect to last for a long time, and then any subsequent calls would just be queued and would never go anywhere. They'd never progress until one of those long-lived streams were closed. And an additional problem is there's very little feedback about what's going on. Like most people won't understand this max concurrent stream setting, and they'll probably not understand why their requests through HTTP client have paused. Are there any comments on what I've said so far?
No, that makes sense. I mean, I'm still not understanding, why do you, you said 100 connections for normal apps would be a lot, but why do you think it's more common to have it to reach the limit here? That's the thing I don't quite understand.
Sorry, reach the limit where?
So you basically said normally 100 connections would be quite a bit for an app, right? But you said in the context of microservices, you can hit this limit much, much quicker.
Well, it's more common for a microservice to have many parallel callers talking to one particular server. You think about.
Oh, you mean on the server, not the client? I see. Okay, that makes a lot more sense now.
Well, no, it's the client, because the client is the one who's creating the connection. I think this max concurrent streams makes more sense in the context of a browser. Like you have hundreds of browsers talking to one server,
Right.
and for each of those browsers, 100 connections, 100 concurrent streams to download images, that's probably fine.
Right.
But when you have one server talking to another server, and
Right.
like all the activity of an application, of a server and application is going through that one TCP connection, then 100 concurrent requests isn't quite so many.
Right.
Essentially, you run into a problem where all of your clients are sharing that one connection because the server is the one creating that connection.
Yeah.
Right, and like I think you said it, James, right? It's the gRPC streaming scenario makes this way more common. Each of those use an HTTP2 request, like each stream.
Yeah, they do.
So to provide a little devil's advocate balance here, the HTTP2 spec actually does say don't do this. It says don't go over the stream limit and don't open more than one connection. But we've seen other clients do not respect that limit. And it really seems it seems like a lot of the industry is okay with kind of going over the limit in certain scenarios, such as the microservice one. Although we have seen reports of some servers kind of detecting this as bad behavior and start returning like error 500s if you go over the stream limit across multiple connections.
Yeah, I think this setting was probably when it was thought of mainly in the context of browsers. Like there's no reason a browser should start opening multiple connections to download one web page. But in the context of a server talking to another server, and all the HTTP activity is just between one client and one server, then multiple connections do start making sense. So some examples of where we've seen other clients get around this issue is Go will actually do this by default. When you exceed that limit, it will just create a new connection for you. Other clients tend to require opt-in, like WinHTTP. WinHTTP, I believe, in Windows has a setting to, like a flag, which you can enable to create additional connections. And I think I've seen Java clients have a setting to create additional connections. So what we're proposing as a solution is a setting which will allow HTTP client to create additional connections when the limit is reached. So rather than pausing and forming a first in, first out queue, HTTP client will instead create a new connection which would reset that concurrent streams limit back to 0, and new requests would happen on that new connection up until the point where the original connection saw less activity, and new requests would then be made on the original connection.
So I'm still somewhat at loss at because of the party that initiates it and the party that receives it. So who would set that setting? The server that initiates the contact to another server, or literally the browser that talks to the server? Like who would set the max HTTP2 connection per server setting? The client or the server? Hopefully the server, right?
The server does. Like the client could have its own setting, which if it decided it had more than a certain number of concurrent streams, it could decide to create a new connection. But the server wouldn't have any knowledge of that. But the setting we're talking about at the moment is the server setting. That's what HTTP client and Socket's HTTP handler receives when a connection is first established, and it is what it respects.
Corey, you mentioned earlier that some servers are looking for multiple connections from the same client and rejecting them if they're for HTTP2 connections. What server was that? Or I was just curious.
I don't recall. I actually don't know if I was given the server name, but I was talking to the WinHTTP guys about this, I think, or something related to this, and they said that they found that problem out there.
Just to reiterate, though, if you have a scenario where, say, a front-end web server is talking to a back-end web server, presumably you control both servers, so you could suppress that behavior on the back end if you really needed to.
I would think so. And I wonder how many. I was surprised that a server would actually block multiple HTTP connections from like the same source IP, because I feel like NAT would like break that as well. But maybe I'm missing something there.
Yeah, I think this setting is essentially a workaround for servers that maybe aren't configured correctly or aren't configurable. So maybe you have a microservice API server that is limited to 100 maximum streams, and you either don't know that it's a problem or you can't change it. So this is kind of working around it by having HTTP client open up multiple connections.
I'll add that setting max concurrent streams to a really high value, there is that does still have some downsides. Like if you did ever have packet loss, then it would affect every single request, because there is still head of line blocking when packet loss occurs on a single TCP connection. And there is probably finite limits of how many requests you can send via a single TCP connection. Like I think if you had tens of thousands of concurrent requests on a single TCP connection, just concurrency issues would eventually lead to issues with throughput. So I think having the ability to open up multiple TCP connections is a better option than just trying to send everything via one TCP connection.
I agree with that, especially like since at least in Kestrel we just run every request on its own stream. Like it does hurt performance with that design. Or sorry, we run like each request on its own thread. I don't know if I said stream or thread, but yeah, that does cause concurrency issues if there are too many streams in one HTTP2 connection.
Yeah, so to kind of play it a little safer and comply with the spec, by default, this will still be 1, but the user can change it all the way up to like int.max value if they want to just go bananas opening connections.
So the properly we're talking about max HTTP2 connections per server. When that's 1, there would be the current behavior. So we're not talking about changing the behavior of HTTP2 with HTTP client by default. The current behavior would still be the default. When you increase this, you could create up to that number of connections. And then when you hit that number of connections, you would fall back to the current behavior, which is that first in, first out queue. And if you set this to int.max 32, then that's pretty much just create unlimited, which was my original proposal. But having a limit like this is fine.
So I'm still not quite sure, like, what does this mean with the 100, the default value for the max concurrent streams? If I set this to 2, does it mean I have maximum 200 concurrent connections?
Yes.
Right.
Maximum 200 concurrent requests, but it would be over 2 TCP connections.
Correct.
Right.
I see. And then basically everything else would be queued.
After like the 200 and first would be queued.
And you said the default value we will be shipping is 1? Because that's the current behavior?
Yes. So that's to comply with the word of the HTTP2 spec, which is to say you shouldn't create an additional connection if you run out of max concurrent streams. You should be patient and wait.
So, Corey, you mentioned you talked to the Windows guys. Like, do you know what they plan on doing?
So they've already done it. They just have a bool essentially setting where you can enable an unlimited number of connections that will just open up if it needs another one.
So they don't have queuing at all. They just say like you either lock after 100 or you have infinite effectively.
Yeah. We chose to go a little more controllable route of allowing the user to cap the number of connections.
Is that because they only care about clients, or is it like, I'm just curious, like why did they go down a different route than we went?
That I'm not sure of. They do have a connection limit for HTTP 1. I'm not sure why they didn't do one for HTTP 2. It's probably because you get so many requests out of one connection that you would really have to be doing something crazy to open up a problematic number of connections. However, we're currently kind of investigating scenarios where the number of connections really matters because firewalls and things like that will just start dropping packets if you go over that. So making it configurable here kind of helps our users stay within their own limits.
Makes sense.
Pavel's been
question.
raising his hand.
Yeah.
Oh, there we go.
Thank you. Is there a scenario where you would manually want to control affinity between request and connection, or like doing route robin or whatever algorithm we implement in HTTP client is acceptable default that nobody would want to mess with?
So the implementation here will actually not be round robin. It's essentially going to try to fill up one connection as far as possible and then spill over into another and then continue trying to fill up one connection as much as possible in the hopes that the other connection will eventually drop when your traffic goes down. Load balancing is a scenario that we considered. It's something that we chose to not solve for now because we think load balancing is kind of a larger issue that we can tackle in other ways through some more sort of low-level APIs than what HTTP client does.
Cool, thank you.
So that makes sense to me. There's one section where you talk about some other property. Is this just this one here? Is this relevant, or is this some alternative?
That was the initial proposal. So that was a flag similar to like what is on WinHTTP, which is basically do unlimited. So really that's just changed to now be an integer, and that integer is the max number of connections.
Makes sense. Yeah, unless anybody has any concerns, then I think that seems reasonable to me.
So there was discussion about should this property name have HTTP2 in it? Because HTTP3 it's not similar in implementation, but it's similar in concept of limiting the number of concurrent requests happening via a single socket. So that discussion's right at the bottom of this issue. I'm not an expert in HTTP3. I haven't looked closely at it, so I don't know how much I can comment on whether it's appropriate to share them and whether we should like what the correct name should be.
Yeah, I mean,
so HTTP3 goes over UDP, which causes a much different load on things like network hardware and firewall and things like that. To me, it makes sense to kind of allow the user to configure both of them separately. But I could see if we were going for, maximum ease of use, simplest API, combining them is an option.
I also vote for separation, in part because Quick doesn't have the head of line blocking that HTTP2 streams have.
Yeah, in HTTP3 and Quick, it makes much more sense for the server to actually set a limit of like 10,000 or something if they actually can service that amount on the server.
Sorry, like when you say HTTP or Quick, like is that the same? HTTP3 and Quick?
The layering's weird.
Yeah, they're the same. They're two different protocols that are the same.
I see. Okay, so I'm as smart as I was before this meeting.
HTTP2 kind of does more than HTTP3 does because Quick gives HTTP3 streams, basically.
I see.
Whereas TCP doesn't give you that.
I mean, from all I was hearing from HTTP so far, that HTTP3 seems very different from HTTP, what we currently have, including 2, that it seems hard to think about what it does to our API surface. Like, I mean, I don't know, HTTP client, while it's a good API, is also, not super young anymore, right? And I wouldn't be shocked if we find ourselves writing a brand new API for that altogether then. So I would kind of say, like, assume that this is HTTP2 for now. And if 3 comes along, if we have HTTP2 in the name, we can split it, or we can say, yeah, it's for 2 and up, right? Like, I mean,
Well,
considering that the handlers are also not
are
the mainline
two,
scenario, right?
HTTP3 experts in the room right now. We actually have an implementation in HTTP client in Kestrel today, so the current APIs are fine. It's really just about resource usage for me. It going over UDP and not having head of line blocking makes me think it should just be a separate setting.
Yeah, I mean, my other
It's
question.
sufficiently different that like the same property I think would be like leaky. Like, yeah.
I mean, my other question
It's
is.
a bad abstraction. Sorry
Yeah.
to interrupt.
No worries. So we put it right now on the specific handlers. Like, why would we not put it on the base handler, and why would we not put it on HTTP client directly?
HTTP client doesn't know anything about the implementation that it's using. So it could be using sockets handler. It could be using the fetch API in WebAssembly with Blazor. So it doesn't know. It really has to be something on the handler. And we've put all of the other configurability options on the handler to date. There's tons of them there.
Okay. And we also believe it doesn't belong in the base handler. It belongs on the actual specific derivatives.
Yeah, then it would be weird if you could set it somewhere and it just had no effect.
So I've got a question about net standard and net 5.0. So currently the gRPC client targets net standard 2.1, and it uses HTTP client handler, and you can see there in the gRPC usage currently on the screen. What we would probably do in the gRPC client is we would create a handler ourselves and we would configure it so there is no limit. So people are using gRPC and they're doing these long-lived streams. New connections will be created as needed. But that brings up the question about how do we know that sockets HTTP handler is going to be available and is the right thing to use compared to HTTP client handler? Will there be some kind of Boolean test to check whether sockets HTTP handler is the right thing to use? Or I'm just trying to figure out, will the future version of the gRPC client that uses this, will it be targeting the net 5 TFM, or will there be a net standard vNext? And what's the way to determine whether to use sockets HTTP handler and set this flag versus using a HTTP client handler?
I mean, it kind of depends on how do you envision the usage in the context of somebody who consumes gRPC. Is that something they would pass into you, or is that something that you do in the implementation of them calling APIs in your end?
I would do it for them. We would do it for them. So when you create a channel by default, when you create a gRPC channel, which is kind of like an abstraction over a connection, internally we create the handler for you. And ideally, we'd like to create a sockets HTTP handler, which has the concurrent stream limit disabled.
And you would,
And
but you would not take like there's basically no. I guess what I'm trying to get at is like, would you ever have a public API that would have to accept the sockets HTTP handler? Probably not, right? Because you would probably always
we
could.
currently let you customize the handler that you want to use, but like if you're customizing it, then it would be your responsibility to set this.
Right.
I'm more thinking about the default experience.
Right. So that means your
when
API
you-
would like maybe just take an HTTP message handler that the consumer can customize. But if they don't give you one, then you would manufacture one. So basically, that means you have two options. You can either multi-target. You can either say, I have a binary for net5 where you directly new up sockets HTTP handler setting this property to false. And you would still have a net standard reference assembly. So that means anybody who consumes you from net standard, the API service is the same. And when they deploy for net5, they just get the better behavior. The other option you have is you still have a single binary that targets net standard, 2.1 in your case. And you would use reflection. That's also possible, right? I mean, whether it's the names of the types, the names of the properties. You would just effectively, do the typical light up that we do, where you probe for the type, probe for the property, and then maybe use a delegate to cache the invocation, so you don't have to go through reflection every single time. But that would basically be the two patterns you would be using. Multi-targeting might be easier because it's not crazy reflection and it's all static. And you consumers don't need to know this. It just works magically for them.
Yeah, I wonder, like, Blazor is the main scenario I'm thinking of, because it would be using a handler which would internally be using fetch rather than sockets. But I'm wondering, like, are they gonna target net5?
Yeah, so the thing with
might be.
when you say Blazor, like I just played over the last weekend a little bit with it. So there's server-side Blazor and client-side Blazor. So my mental model is probably not the best one. But the way I understand it is that we don't have a TFM that's specific for Blazor, but there will be a RID that is specific for them. So their own implementation can totally have a binary that is different for what the client would get in Blazor, right? The actual thing that you send to the browser to execute. And that one would basically do the right thing and go through the fetch APIs. But basically, logically, they would both be targeting net5, both the client and the server. And so basically, you do the differentiation via RID-specific binaries.
Okay.
Yeah, it's my understanding that the Blazor, client-side Blazor, will just instantiate HTTP client using a different handler, so it won't even be using either HTTP client handler or sockets HTTP handler.
Yeah, it's the fetch handler, right, or whatever the thing is that we call it, right?
Yeah, it'll be like WebAssembly handler or something like that.
Yeah, something like that. And the downside is, like, you don't want to generally do that for other people's projects because targeting RIDs is a pain in the ass, given that we basically have no tooling. So I think in your case, you would get away with just doing the normal multi-targeting via TFM, because you don't really care whether you're in the browser or not, I suppose, right?
No, or as long as things work, as long as when you make the call via HTTP client happens.
Right. And then Corey, remind me, like, how does it like if I do a new HTTP client in a Blazor client app, or I should say in a WebAssembly Blazor app, like, I'm not passing in a handler. Like, so the default constructor will then manufacture the one that takes the fetch thingy?
Yeah, and as far as I know, WebAssembly has no support for sockets, so I'm not sure what will happen if you actually instantiate a sockets HTTP handler.
So that
Probably
means
blows up.
Would fail.
Yeah, so I guess worst case what you would do is you would just say, if OS platform is browser, then you say, instead of saying new sockets handler, you would say, new HTTP client or whatever, and then you just use the default handler that comes from that.
Okay.
Levi's been trying to talk for a while.
it's actually a related question based on the fact that you don't necessarily have control over what handler you're using. Is there ever a scenario where a caller of HTTP client would want to know whether the request has been dispatched immediately or whether it's in a queue waiting to be dispatched? Is this important for gRPC, for instance?
There are important scenarios for that, and we're working on other APIs to solve that.
Okay, great. Because it seems like it dovetails with this pretty nicely, honestly.
Yes, absolutely.
Is the idea that that would come in perhaps in the 5.0 timeframe along with this, or is that future?
That is future. We're going to be launching an experimental package with some new APIs for that, and depending on how they go, merge them into .NET 6.
Okay, awesome. I'm glad that that you're thinking about that. Okay, cool. Thanks.
Sweet.
So
I guess...
James, with gRPC on client side Blazor, will that be true gRPC, or does that have to be like translated to be like gRPC over I forget what it's called, right? But you have that wrapper to do it
gRPC
over
web, so it's not true gRPC, but all the APIs are the same. The user experience is pretty much the same. The only slight difference is it could be over HTTP 1.1 or 2, and the content of the message is slightly different to include the headers.
Okay, and with gRPC web, if it is over HTTP2, it's still like a request per stream or whatever, so it's similar in that regard.
Yeah.
Okay.
So unless there are any more concerns, I would just approve the API as is, and then we can go into the weekend.
Yeah, I agree.
Excellent.
Emo, we need to give you a gavel so that you can, smack the desk.
I can just fist bump the desk.
I call this API review to a close.
Will the gentleman yield? It's hopefully a phrase I never have to use. All right, so then I think this is it for today. Anything else that we need to look at? Because we have 20 minutes left. If there's anything else, James, you want us to look at, now is your time.
Oh, I've got a OneNote where I have
A OneNote.
Yeah, actually there is something we could look at. 31198.
31198. Dum, 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 dum. I guess there's no proposal for an API, but there's.
There is where in my post and my comment.
This one here?
The one that's on the screen?
Yep. So I haven't looked at this issue in a little while. Let me just go back to the discussion.
Has the networking team gone through the approval process with this yet? I can't recall if we added a comment or something saying, is it marked API ready for review?
No, it's marked API suggestion.
Okay, yeah. So then we need to talk with the network team about this before it comes to this meeting.
Okay.
Anything else, James, you wanted to sneak in?
No, I think that was the only one. Unless you want to talk about connection abstractions, is that still going?
I think that is another meeting that we have. There's one more, right?
Yeah, we need one more scheduled. I don't know if it's scheduled yet.
It's not controversial at all.
I'll leave that one to you guys. No, I don't have anything else.
All right, then the meeting shall be adjourned, or whatever the phrase is. All right, then enjoy your time down there. You're the only ones who are out of COVID, I think.
Yeah.
Don't hurt yourself too bad in the gym.
Okay.
And
Bye.
for the rest of us, enjoy your long weekend.
Exactly, Independence Day. All right, see you guys. Bye-bye.
Bye.